Hello dear researchers, I hope you are doing great. In this tutorial we are going to learn how to run multi-analysis of variance, that is MANOVA, on Likert scale data or ordinal data. So I'm going to show you the major steps that should be followed for this analysis using of course spaces. And as you can see here on this variable view, we have some items of Likert scale like regular assignment of homework from this to this. So there are like some items and there is a 5-point Likert scale. So the first step that we need to do is that we need to compute the mean score of all these items together and get one variable like this one. Okay, so I'm going to keep a link to a video on how to do that in the description box or in the comment section so that you can do it. And so since we have here three Likert scales, we have regular assignment of homework, we have the kind of homework and the beliefs about homework. So we are going to get like three variables, continuous data, and I'm going to label them respectively regular assignment of homework, kind of homework, and beliefs about English homework, as you can see here. And even if we go to the variable view, we are going to find the mean score of each variable respectively. So the procedure that we use to get this variable is, as I said, is about or is through computing the mean score, and you can do it using transform, compute mean, or compute variable, statistical, and then mean score, and we keep putting variables here or items of each Likert scale till we finish. So I'm going to keep a link to video on this. Then the next step is that we need to see the or check the normality of the data on these three variables. So I'm going to keep also another link to how to check normality and interpret the results of Kolmogorov-Smirnov test or Shapiro-Wilk tests, depending on the size or the sample size of your study. And then once we check the normality, we we need to check also the third step is that we need to check even whether or not there is any outlier. So what we mean by outliers here, these are extreme values that deviate from the normal distribution of the data. So obviously we can do this using like sort function, or we can use another test, the Mahalanobis test. I'm not going to delve into this, but if you want to test that, you can just go to analyze, regression, linear, and you put no variables here, and we put the group into the dependent variable, let's say here age, and in the save you check Mahalanobis test. So this is the name given to the person who came up with this test. So click continue and OK, and wait for it. So what we will have no variable that is created here. So depending on the significant level or levels, we need to check that should not be higher, like beyond 14. So we can check this visually if we have small data set, or we can, order this from, the smallest to the highest. This means that if we find some values that are extreme, we can eliminate them. Like this one, 16, I just spot it. We can eliminate this response just for data cleaning by going here and clear. Anyway, so let's suppose that all the assumptions are correct just for the sake of simplicity, and go to run the actual test, that is the MANOVA test. So we are going to go to analyze, and we're going to go to general linear model, and then we go to multivariate, and we're going to move the variables that have been computed, or their scores or mean scores have been computed, to the dependent variables, and the independent variable here, let's say age, into the fixed factor, and we go. There are many options. For the model, we can keep it for factorial, and for plots, we can move this age here to horizontal axis and then add it into plots. Click continue. Then for post hoc tests, so post hoc tests tell us where the difference actually exists. When we find like there is a statistically significant difference in the different age group, we need to see where this difference occurs. I mean, which age category, I mean, younger or older people. So suppose that there are variances that are, or equal variances that are assumed, we can go for Schiffe test. Okay, for post hoc we go for Schiffe, but if the equal variances are not assumed, we can choose one of these. Can choose here Danit C. Okay, so every option that I check, it will show up in the or appear in the output. Okay, so I click continue, and for the means we can keep it this way, and for the save we can keep it also this way. And what is important is the options. So we are going to check descriptive stats, estimate of effect size, etc. And any option that we are interested in, we can find it here, like homogeneity test, to check the assumptions at the same time. So then click continue and OK, and wait for the output. So it will take some time. So this is like descriptive stats about age and the mean and the standard deviation and the number of each group. And this is the sig value or the p-values. If the p-value is below or above 0.05, we can see that there is statistically significant difference. In case it is below 0. Or equal or below 0.05, depending on the levels of significance. Here we can see this visually. There are no statistically significant differences, so we don't need the post hoc tests at all, because there are no statistically significant differences anyway. And these tables tell us the exact variable or the values for each data set. So this is how we go about doing or analyzing Likert scales using the MANOVA test through its spaces, of course. And if you have questions or remarks, do not hesitate to post them below or contact me via my social media. I try to answer as many questions as possible, and I hope to keep answering and keep posting some interesting content for you and for research in general. And see you in another tutorial. Bye for now.